you don't see it, but I bring everything on table from coffee to water to snacks. And let me share my screen, and just to be assured that
Iman, you're muted.
thank you for saying it to me. I was gonna think I bring everything to table from coffee to water, and rest to be assured, we came up with some example file for this workshop, and we will give it to you at the end of tomorrow, actually, because we want you to try and figure out the concept yourself, because you might want, for example, to change the schedule of lighting to something else. And in order to do so, you should be familiar with concepts. If you have not, and there is no question remaining, let's go for the most interesting part, and that's assigning the materials. Are you okay with it? So let's go on. Fun thing to notice, if you go to Honeybee and you go to Honeybee Visualize, we have this thing called HP Room attribute, and if I go to HP label room, I could get my result room. No difference from this part. And ask for any sort of data you want here, and it would give you the results of that. It is helpful if you look for anything specific and want to figure out, for example, what are the materials, what are the construction used. You could use these components, but we miss one tab here, that's construction. Also from last session, we missed the modifiers tab too. Why we have two different material? We have one material for lighting, one material for energy. Because the simulation engine for these two are different, and in order to make materials, you should go for two different paths. So let's start from here. We have a HP construction type. I put it here. And another thing we have here, HP construction set by climate. Okay, interesting. And one other thing we have here, we have HP construction set. And one other things that we have here is HP search construction set. Okay. Let's go with the easiest one. HP construction set by climate. And I have my climate zone here. As I mentioned, we have HP building vintage here. So if I'm in a cold region, I could put cold, cool, mixed. No matter, I just toggle in the cool and toggle in the construction type, the steel frame. Of course, we could go for wood frame, mass building, metal building, anything. And let's go for mass, at least in this case. And what we want to get from this construction set. It said, let me bring up my panel. It is saying it's 2019 climate zone 5 mass. So what we could do here is similar to what we did to the program. HP deconstruct construction set. And in construction set, we have construction like walls, like roof, like exterior floor, and etc. So now we want to deconstruct the construction. I know it sounds a little bit too much or thing, but that's the way Ladybug team group manage data. So we have here now layers and materials sorted out. We have materials and we have its layer. For example, it has 1-inch stucco, 8-inch concrete, high HW stand for high weight, and it's from reference building, typical insulation R10, and from 1.5 inch of gypsum. As you could see, it goes from outside to inside. And if I change, for example, here to subarctic, you see nothing changed except insulation. Or if I go to very hot, the insulation change. Why does insulation go up from when we go to the colder region and it goes down when we go to hot or very hot region? That's something contradictory because when we usually talk about insulation, we are talking about having our space insulated. And no matter it's hot or cold, we want our interior space insulated. Uh, it's because of one effect that when you use thick insulation, you got your building breeze isolated and your building couldn't breathe. It's so much similar what you're facing probably now when you sit in a car and all the windows are up. It's like, I don't know, no air could go out or could go in. And in these scenarios, you could see the benefits, some benefits it has on energy simulation. But let's review it. Does it work or not? I have my building from previous session. You could know that I could bring HPNO load and toggle my room. And from EPW file, I go back to my Berlin, Germany. By the name, I wasn't living there, but by the name, I know it's in Germany, it's in Berlin, so it's cold. So I put it on a cold as a construction, and I want to assign my construction at this step. Here, I go to HP, apply construction set. I get my room, I get my construction set, and let's put a toggle, Boolean toggle, click on a run and set it to true. Of course, it would take so much more time because, okay, what's the problem? Okay. It takes much more time to do so because of all the assignment and changes with them. You may encounter errors like this, and here we have report. How should we fix this? It got severe error, duplicate name for people and light and objects. It's related to what? It's related to the program we have here. So best thing we could do, as you could see here, the name has 2 underscore. It means that it's not necessary to assign name. One thing I could do is just hold my control and not to put, you could see here, I have 2 name assigned to single object. I could get rid of them, and here it is. You see everything works fine, but we somehow miss the names. Okay, so don't get panic out or anything. It's just simple error. Always we could fix it. Okay. For zone name, we have overwriting existing object, lighting, and let's check what other problem we have or we might have. Duplicate name found. Okay. Let's go for a default program here. And check it one other time. I toggle this to true. Okay. It said we have existing program. Okay. And okay. So there is some cool trick we could do here in order to somehow we assign program differently. So let us run this again and check if the problem is based on program. So it's not actually based on our program, it's based on what we've done that before running it, it's actually upload all these file as an input in our running Energy Plus program. So I would save this file, close it, and close my Rhino. Okay. Again, no, I don't want to save this file. I go to open. As I said, first Rhino, and then everything else. So we wait a little bit. Do you remember the word I said about putting up the name with no spaces and things like this? That would be also may cause some problem for us, but we figure it out soon. Okay, the menu is not going to be loaded. We type the grasshopper. As you could see, it's here suggesting there are lots of overwriting rooms. Okay, let's take our annual load and go step by step to solve what is causing the problem. Let's start from here. I have rooms and I've made changes to these rooms through my simulation. And by this, I could figure out what's causing the problem. As it seems here, the moving object is causing problem. Why? I will tell you. So let's toggle back my program, my base programs, and test them out actually. Okay, here is my bedroom program. Here is my room programs. Yeah, we could talk about wind direction too. And here is this program, and the last programs goes to this, and everything seems fine. Let's toggle this through, and everything is going fine. But why after this solve adjacency we have problem? And when we go to report, it says it has duplicated name. And because of that, I have some doubts is because of program we write. It's not because when the HP object move our object, the room name remained the same. And even after this solve adjacency part, it's still the same. So what should we do in these cases? What's a rational choice in these steps? What you could do, of course, we could rename the rooms for ourselves, or we could came up with solution before all of this that is causing our main problem. What's that? That's having our room and our solids in different setups. So let's go and make a move component here. Let's add move. Here, and what I want to move are all of these geometries with this. So let's go back to geometry. As you could see, I have it closed burette. Like here. Why I don't have enough burette? Like I put on a list and it gave me 8 burette. Let's see it. They are not all moved. What should I do? As you might know, we should make a graph here. So I have set of rooms in this manner. Or they may cause problem, or we could make these differences after this bank. I'd rather to do this because it would give me a huge chance to somehow manage my output. So let's go and toggle these geometries all to the room, or a much more simpler task we could do is it toggle this in, and we have our move geometries like this. Of course, it came from Bang. Now I should make some simplify here and here. And if it's needed, I should shift a pass or make this list graph also. Let me bring up my graph. And here it is. And so let me do one thing, and that's our geometry, and that's the partition size. Okay, here, if you see, we have each partition size for each of the units. We could do some trimming here, trim 3. And after that, connecting to Bang and again match output. So everything is fine, but we have one problem here. If we go to HB, Honeybee, and bring out the visualize tab, HB visualize by type, you could see all these spaces are in this room or here, which is not well represented about what we want to do. So we should bring a flip matrix so that let me click on match output again. So that we have bedrooms are in one layer. Let me open up some space here. So that we have our bedroom in this layer, our room in this layer, here it is, and you could see different rooms are all in this. Let me check out. I think these two should go to this and everything seems somehow fine. Oops, we miss room here and that should, okay, that should go there. Okay, let's go and check back. 1, 2, 3, 4, 5, 6. And we have 8 output here. And okay, it's because of the partition that we did here. Okay, let's do this again and do the partitions and make them go after this bank. We make match output, and here is goes to this, and this geometry goes to this. And for easier job, I could move them like this, this, and also this, so that I could manage my list. As I said before, of course, you could write your Python algorithm to manage list structures like this, but for the sake of this workshop, we don't go dive deep on writing a Python script. Here, here, and here are this list. Here is my geometries, and here are my own. So let's go and check it out. Everything seems fine, but we have one problem here. And what is our problem that we are facing here is that the partition list we did earlier is not working. What we could do a simple task and flatten this list. And what we do with partition is just size of these partition. We could multiply it by the number of floor we have, so that the partition list for this time is going to be working fine. So here I have my room solved, but something is wrong. Let's check it out. Okay, we have this, we have the list has some problem. Maybe it's just because I didn't connect correctly every item 2 by 2, 2 by, and 3 by 3, 4 by 4, and fifths 1 by fifths 1, merge it all together, and we bang the tree. Let us check the rest. Okay, it's fine. It's fine. It's not fine. Okay, we have problem right about here. The second and the third list. So I should check back here. We have one, we have our second one and the third one, and we've merged it all together. Okay, 1, 2, 3, 4, 6. Oh, I know what's what's making us what's actually is happening in this list, because let me explain what's causing the problem. Let's go to param and take out our param viewer. Draw a tree. Here is the list of the tree we have. We have 3 spaces, but in these spaces we have rooms. So what it does, it's change the direction of the rooms. So in order to solve this, we have, I'm not against putting components, but it could be solved by something like this, that we just copy and paste components. Here, put up a list. And also check out this toggle. What I would want to do is I think in this way it's understandable for everybody what are we doing. But for expert, I suggest you go to set. It's actually what I usually do. Go to tree and we have path mapper. With path mapper, you could easily map these trees so we don't get complication like this here. Okay, everything is fine, and here everything should be fine, and also here. But unfortunately, I have to inform you here everything is not fine. Let's go check it out. Let me bring out my geometry. The walls are correct. Okay. The interior walls, we don't have it because we put air wall. We have air wall. But what it does, it's do air wall for floors. When do we have air wall for floors or ceiling? Imagine concept of you are having a duplex villa or something like this. Or to be honest, the stair box has no floors at all. It's just a single unit stair box. So what should we do? How could we manage these sort of data? First thing first, let's go for visualizing. Here are our living room that we merge. Here are our kitchen, and in here are what we have at this stage. And here is our stairbox. So let's make all these right. I think it was a good review of what we were doing. First thing first, I make my stairbox as one single unit. What do I mean? It has no ceiling at all. A single wall with all the rooms. That's it. So, as I said before, we shouldn't have any duplicates. So we take this toggle. But what about the floors we have? What should we do in order to not found the adjacency of these floor we have? As you could see, here we have items. And unfortunately, the living room we have make this item, we couldn't not partition again these lists and solve it again and then go for something else, something like this. What could we do? Uh, there is a solution that we could go for here. What's that solution? We want to take each of our item and put it on a single list. So let's get our list item. Let's first bang this tree. As I said before, just to remind you why we are taking all these efforts, it has very simple reason. Because we want, after we've solved this, it's no matter what room you have or what layout you have, you just draw the layout in the layers. Since we take our layer with geometry pipeline, you could change it to whatever you want. Let me type grasshopper again. So what we have here is merge all this. So let's get solve adjacency of all this. With no air boundary. It seems fine. Am I right? Now I have all the rooms. The walls are correct. The roof, the ceilings are correct. But we have interior walls instead of air walls. So what should we do here? We could came up with solution to get rid of these rooms and make these rooms into separate spaces. But you would say, how could we do that? What's your solution? I said, let's bring a flip matrix here. Oh, sorry. Flip matrix. What it would get us is a list of each room in each floor we have. For example, let's see it. All these room here, all these room here, and it's not even in a single correct list. Why? Because we have living room, two rooms beside each other. So let's go back to this item. And here we could again do partition list. How? Again, by getting list lengths from this component. Three list lengths. Now we could flatten this list, and as a result, if I put bang 3 and put a simplify and match output, we have all my living room, all my kitchen, and all of my interior zones. What we would do at this stage is just bringing merge components and merge this input. How do we merge this input? It's like we should do one list partitioning again. Why? Because we want them to be specific in one floor. Let's go to chat and does, let me rephrase it. Does anybody understand why I'm doing this? Let me stop sharing my screen. Okay, hi guys, I'm Iman. Are you there? Okay, let's put it again in great. Let me share my screen again and talk what I'm doing and why I'm doing this. During my speaking and teaching and lecturing in different way, the most problem people have is not with program, it's not with material, it's with solving these geometries. Let me draw something here. For example, I have this building right here. Sorry for my bad drawing. Okay. What I have between these floors is actually a ceiling. So it's not air wall. But think of a same space which is duplex, which is like a stair box. And what I have here is just like air wall. So I could not toggle, make these two similar. Because here in this space, we said these are air walls, which means the wall I draw here is not present. It's just imaginary wall. Why? Because they have different heating and cooling supply and lighting conditions. And I want to make all these spaces air wall, but not their floor air wall. As a result, I should have them in different list in different floor. And I should solve the flooring differently and solve the air wall differently. Because of all these adjacencies, that's causing us a problem, a huge problem. So now I hope you get what I'm talking about, and let's solve the last step of this puzzle. So I click on partition list. There is one in the chat. Okay, it was clear. And for partition list, which is for my 3 spaces, I bring my list and I use this size. So let me bring my HB visualize so you could see it. Here are my spaces. Here are all of them stacked here. And what I want to do is make a partition list out of these spaces. So how long partition should be for each list? Let's take back here. I want this merge list. Oh, no. I want my interzone. I want my kitchen. And I want my living room links. Or we could put it by hand, but I don't want to do that. So let me check out. Is everything fine? Okay, instead of list links, I tile. So here it is. So if I draw anything else, nothing would have happened. Okay. And we should graph this list so it matches with this list. And now if I bang these trees and click on match output and click on simplify, we have each of them on a single part. So the last thing that we want to do here is just flipping these matrices. Oh no. Here I should add my flip matrices, and here I connect it to my bang and match output and everything. No, I should trim this tree after that. Let us go this direction. Okay. And I want it to be matched. And let's merge them. So let me bring a solve adjacency here. And I should get so let me do one simple thing, multiply this by number of my floor. So it's equal to size of my partitions. And maybe I could flatten it in this way and check out the room with HB visualized by type. of course, after the banging tree, and click on match output, and so what's wrong with this? Okay, it's not in a single room. Let's bang this match output. Okay, no flattening here. Just match output. And of course, we could do floor by floor. I have nothing in my mind right now as a solution to this problem. So, okay. And it's would get flattened. Let me change this. Okay, Control C, Control V, and no, this time this and this, and here it is, 1 3 2 3, and the last part here it is, 1 4 and 2 4, and we want them to be solved, not only solved, but overwritten also. And here are them. And we merge them, and hopefully everything is solved. We have now these rooms. That should be connected here. Oh, we've missed some. It should be connected here. The list of risks, and let's check out by visualize by type. And here are my rooms. And let's go for geometry. Geometry. Here are our wall. Here are our interior walls. Here are our air walls and ceiling, and where is floor? I don't see floor. Interior floor. Everything is fine, and Let's click on annual loads this time. Again, we have problem. Let's check it out this time. Here is our report. Okay, my computer freezed, I think. Okay, it came back. I want to read the again. It seems it found duplicate name, but let's see what rooms we have. It's duplicated. Okay, let's put false toggle here and take our components and go back to the list so we solve it step by step. Let's recheck first the see what we get from again. We have 6223 and here we have again numbers that are no, it's okay. 636, 637, 646, and 47, and we got 56 here and 57 here. Let's put the name we want. Let me go for B, for example. Oh, not mode set. Okay. The next one is bathroom. Let's type it all in and then paste it and drag. Here we have bed. After that, we have our bathroom. After that, we have living room. Living room. After that, we have our kitchen. We have our stair box. I call it a stair. And we have our inter zone. And we take all of this and go by here. And we connect the names together. So that we have correct names for each of our rooms. The name living, And here is our kitchen. And here is our stairs, and here is our interzone. Okay, and let's check out running again. So we could easily now figure out which room is causing the problem. Bit one, and bit 10 with bit one, and also some problem with setting thermostat on living room 5. Okay, let's make it all sorted out somehow. Here I have my boundary surfaces extruded. I want to make one change here, and instead of moving my objects here, I disconnect this. And also disconnect this program. And disconnect this room program. And let's do one solve adjacencies for all. I would sort out and group all these files so you could use it again. Okay, let's go for the report. From what it seems now, okay, we have 12 set points here, which means some objects are copied here. Let's just save this, unload, and also save this and bring out our grasshopper. And what I want to do is running these rooms so I could figure out what's Okay, it's fine. It's fine. Let's go for the merge one. Okay, it's fine too. So till here, everything is fine. So I make some changes and I bring up my HP solve adjacency. I don't know what's causing the problem. Toggle it and run it. So it's turned out to be true. And let's go for visualize by type. Check everything out. And geometry, roof are fine, walls are fine, and ceilings are fine. Okay, let's toggle it back onto my room. And it's fine too. Okay, let's go back with our programs that we make. Here is my program, my bedroom program. That is also working fine. So let me stop this and again set program to different spaces accordingly. I know, maybe wiring it in and out is changing something. And at last, we assign our corridor program to stairs, and that seems fine. We solve adjacency, and let's put it on a run. So everything works fine. Let me save it out. And oh, look what I did. After taking this toggle out, I put again moving, and that would be, of course, causing the problem because we have a multi-story over each other. So if I toggle this to this solve adjacency, I should have probably correct rooms here. Let me check it out. Okay. Now let's check all of it out. And let's bring our panels and do one other simulation to figure it all out. So hopefully it will show us the result. Okay. So I want now to assign my construction set and material I've made. So go for designing this room. It will take about 30 seconds for each simulation and more. So let me record my data or internalize this data. Bring out number and internalize this number. What is 6 cold? We use cold construction set. Let us put it on a, I don't know, sub-archetype construction set. We want to know if changing the only insulations would change our result or not. So here is, I think, 8 sub-archetype, 8 and sub. And let's put number in and internalize data. And for very weird comparison, let's go to very hot. We reviewed it together that changing this component would result on changing the insulations, and we could use insulations here, as you could see, is go for R1. And let me copy and paste this component and go for again total load. One, I think is the name is very hot, something like this. And internalize data. Here you could see difference for cooling. What we did is that when we increase, as we talk about breeze insulation and all these concepts, by increasing the insulation, the cooling demand gets higher. You could see it here. Let me here, here, and here. But the heating demand, as we increase the insulation, gets lower. That's what we talk about, finding the optimized solution in this scenario. Our region is cold, so heating is not an issue. But for mixed region or something like this, we have serious problem. If you all agree, I think, if correct me if I'm wrong, Sharif, in 8 minutes or so, we have our guest. Maybe we could have a 10 minutes or 15 minutes break. And after the lecture of our guest, we would continue to figure out the materials, and tomorrow we go for life cycle assessments.
Thanks, Iman.
Okay, great. Let me stop my sharing. So see you in 8 minutes or so. Hi, Travis. It's good to have you here. We just make a break for participants to get relaxed, and it's wonderful to have you here with us. I think people will join because we set a, I think, 10 to 15 minute break, and it's great to have you.
Hi.
Hi everyone. Today we have a special guest from One Click LCA, dear Travis. I'm really happy to see you, and I'm really thrilled to have you in this workshop. Iman, what's your idea about continuing our workshop now?
It would be great since Travis is here. By the way, I think we have some viewer from YouTube, and the recording is live on Digital Future YouTube playlist of this workshop.
Thank you.
We are all yours.
Okay, I guess I'll take over from here. As Shaggy Egg and Iman mentioned, my name's Travis Dahl. I'm actually joining you from Canada. I'm not sure where everybody else is calling from, but it's pretty usual for us to get viewers from all across the world. So it's yeah, hopefully I'll be able to add some value to everybody here. And I presume that everybody that is joining, I'm going to make a couple of assumptions just about backgrounds. I assume that everybody's studying design, architecture, engineering.
I suppose that you stopped it.
Yes, I think Travis has some problem with connection. Maybe I could share my screen about background of people joining this workshop.
Sorry, we missed you. Okay.
There. Sorry about that, guys. I am just going to make a quick change to my network here because I was worried that it might disconnect on me. Just give me, but sorry, carry on.
Great. Travis, I was just gonna share the professional and background of the people joining this workshop. Usually all of, as you could see here, of them are architect. All 46 at least. I just stop sharing and screen is yours.
Perfect. I'm as I mentioned, I'm just going to give it a second. I want to switch networks. I just want to make sure I have a stable connection here.
Great.
And shoot me a message in the chat if anything's not working. I'll try and keep an eye on the your images as well. If it looks like they froze again, I'll pause and just want to make sure everything flows smoothly today. So yeah, as I mentioned, well, what I'll do is I'll just share my screen. I've got I have a slide deck that I'm going to go through with everybody, and we're going to kind of start at the beginning. I'm not sure what everybody's background of life cycle assessment is and how familiar you are with embodied carbon and these sort of concepts. So we'll kind of start at the beginning. We'll go through some of the foundational concepts and we'll work our way up from there. As Iman and Chege mentioned, I'm joining you from One-Click LCA. We're a software platform where we provide solutions for everything related to the life cycle assessment supply chain. So we'll get more into what that looks like in a little bit, but we'll also be going into some of the software tools, how to optimize buildings for embodied carbon as well as whole life carbon, and then I figured that'll probably take us 60 to 90 minutes or so. And I imagine we'll probably have some questions at that point, and I'm happy to go into any direction you guys want to go from there. So without further ado, I'll share my screen and feel free to interrupt Iman and Chege if you guys want me to stop or pivot or something, dig into something a little bit more deeply. Please just jump in and I'm happy to do so. Oh, I do not have permission to share my screen, so would you be able to change that quickly?
Of course.
Great. Second to load. Great. Can I get a thumbs up just confirming you can see my screen?
Yes.
Okay, cool. Great. So as I mentioned, what we're doing at One-Click is it says powering the makers of a zero carbon future, but I would really change that to empowering the makers of a zero carbon future. We've got a huge challenge ahead of us. I'm going to go into a little bit of this. I'm sure most of us are familiar with a lot of the things I'm going to be touching on, but reducing our carbon emissions is it's a pretty substantial challenge that we have, and we don't have perfect solutions for it yet. We don't, as a society, we don't know how we're getting to a zero carbon future just yet. But we do have tools available to us where we can have substantial impacts to the way that we're doing things currently. So we're gonna dig into this a little bit as we move along here. There we go. So I've titled this talk "Incorporating LCA into Your Existing Design Workflow," and this, as you're moving from school into the professional world, this is going to be something that's going to be more and more important from a design and architecture perspective when performing design on any projects. And we're going to look at how we can have the biggest, most cost-effective impacts on the carbon emissions of projects as we're moving forward. So a couple learning objectives that I want to go through here is I want to make sure that everybody's able to understand the importance of embodied carbon, how to define embodied carbon, and how to use LCA for designing our built environment. Objective 2 is to be able to identify the different aspects and metrics of a whole building LCA. We're going to explain what those things are, obviously, and dig into that. objective 3. You're going to learn some of the markets and value proposition for performing LCA. We're just going to touch on these things. We're not going to go into too much depth in that, but there are definitely market-driven value offerings that are driving this market and adding value. And then lastly, I want you all to know how to utilize LCA data within your existing workflows, and then be able to use this as you're moving into the design field, and be able to apply this in the space. Good news is that we're taking an extremely complicated process and using software tools. We've made it fairly simple to do. Actually, I thought I had a title slide on here for myself as well. Just a little bit of background about me. I'm not an architect. I'm not an engineer. I'm not a designer. My background's in construction management. And so basically, I've taken enough of those different fields to be able to communicate with everybody. But ultimately, while I was still working in that space, my training is really to communicate with everybody and keep the job on track, on schedule, keep things within cost, and basically be the liaison on projects to make sure everybody's doing what they need to be doing. I think one of the important aspects of that is the fact that I can perform an LCA, and we're going to be doing this together. Just shows how easy it is to do with effective tools. Not having a Revit background, not having a solid design background really doesn't impede me in the space. So I think that's just going to be really a powerful indicator to how easy some of the tools are to use. So moving on, why do we care about carbon? Why do we care about embodied carbon? What are we talking about with all of this? We'll just touch on some of the climate change issues. We're obviously seeing a lot of the effects of this around the world, this year, last year, over the last 5 years. We've had, we're starting to have more and more frequent 100-year events on a year after year basis, which is, it's pretty alarming in a lot of cases. And where this affects us is we're doing a huge amount of construction over the next 40 years due to replacing existing building stock, upgrading damaged buildings or buildings that are no longer effective, or just trying to house a growing population. We're expecting to double our current building inventory over the next 40 years, which is a huge amount of construction. So basically, that's the equivalent of building a New York City every single month, and that's basically that is what we're doing right now. So that number of buildings and at that scale is really what we're completing on a monthly basis. Again, we're expecting to double the cities over the next 40 years. If anybody's paying attention to the total carbon emissions for what we're doing on a global basis, just the buildings alone, that's another 230 gigatons of embodied carbon, or I should say just carbon emissions. And we're I think actually my slides are a little bit mixed up here, but actually I'm going to jump ahead. I've got another slide. Where is that? Okay. Sorry, I think I may have blanked it out. If basically what we're doing is we're emitting 51 gigatons as an economy, a global economy, on an annual basis. That's the approximate annual emissions right now. And when we look at the built environment, 40% of those total emissions are coming from construction, from the built environment, from the buildings that we construct. So there's a couple of figures within here. So basically all of us being involved in the construction industry, we have a responsibility for 40% of those emissions just related to our industry. Often what we'll hear, and this is an important piece of the picture, I'm not here to degrade this at all. And we absolutely need to continue focusing on high performance buildings and building operational emissions. But on a global, it's important to understand the factors here. Where basically a third of this 40% that's related to buildings is related to the building operations. That's on a global basis. If you are from Canada or the US, like myself, this ratio of this other, the building construction and other related to the building operations, this is actually a 50-50 ratio. We're pretty close to a 50-50 ratio. So the reason for that is because we've already done a lot of work decarbonizing the energy grid that basically powers, heats, cools, and keeps lights on in our buildings. So the impact of this is actually a little bit, it has shrunk, making more space for the embodied carbon of the side of the picture, which we're going to get into in a second here. So what is embodied carbon? What am I talking about here? So basically the operating, we have two identities of carbon emissions when we're looking at buildings. So we've got the operating emissions that I think everybody's familiar with. That's heating, cooling, keeping the lights on, and the emissions associated with that once a building's complete and in operation. The embodied carbon side of the picture is the emissions that are associated with the raw material extraction, the manufacturing, transport, and any maintenance, repair, replacement that's happening throughout the life cycle of the building, end of life scenarios like demolition, recycling, deconstruction. What are we doing with those materials at the end of their life? And basically we're modeling and calculating all of these different aspects into a building and determining what the impact is of that, and we're measuring that on a CO2 equivalent basis. We can go into CO2 equivalent well, I'm sure most of you are already familiar with that, but we basically created a common unit of measurement, and that's CO2. But as we know, there are a number of products that have higher emissions or sometimes lower emissions, but we still measure those on a CO2 equivalent. So that's ultimately what we're looking at there. This is a little bit more of a visualization of just of this definition of embodied carbon. So we're going to get more into this at a later stage, but what I want you to remember at this point is that we have multiple different, like, how do we calculate embodied carbon, and how do we look at breaking up this big and fairly complicated picture? So basically, we have we have different life cycle stages, and we break this up into little manageable pieces. So basically we have A1 through A5. This is our cradle to we'll call it cradle to gate for now. Generally, when you hear the term cradle to gate, we're talking about getting the materials out of the ground or out of the forest, wherever it's coming from, transported, manufactured into whatever the product that's being installed into the building, and then having that product delivered to the site. So the gate of the site, that's what we're talking about when we're talking about cradle to gate. We also have cradle to grave, which is really what's shown here, which is our A through C. So what's happening with that product throughout the life cycle of the building. If we are talking about, let's say, a window that has a 25-year lifespan, but our building is designed for 50 years, we're going to have to replace those windows at some point. And there's probably going to be a certain percentage of them that fail throughout the life cycle. So we have to repair or replace those windows as well. So how are we measuring that and keeping track of that? And then what are we doing with this stuff at the end of its life? We have to deconstruct or demolish the building, move the waste somewhere. Maybe it gets thrown away into a landfill. Maybe it gets recycled into new products. We want to look at these things and make our best guess at what's happening at that end of life scenario. I'm sorry, let's go back to this. I am going to dig into this a little bit more. So I do have some better visualizations for this. This one's just nice because it does have imagery, just kind of showing what the different stages are. I always like showing this chart. So this is from Canada, and it's a little bit dated. You can see it's from 2013. But why I like to show this chart is that it shows the relationship between operational and embodied carbon. So over the last 50 years, we've been focusing on reducing our operating emissions, and that's what's shown in red here. So basically, our vertical axis is year zero, or I should say day one of the operation of the of this building. And as we continue to use the building, those operating emissions accumulate to a total number at the end of its life, where by the time we demolish this building, we've consumed, or I should say, we've emitted this this amount of CO2. Something I think that's important. There are a couple of really key aspects here. So first thing I want to point out is that this is a linear line, and so when we model a building for future operational energy emissions, we assume that the current state of the energy grid is the same, is what it's going to be throughout that entire life cycle. We don't model for proposed changes or what we expect to happen or possibilities. We assume that what the state of the grid now is the way that the grid is going to be over that entire lifespan. That's important because, I mean, that's the right way to model it, because, you know, we don't know what's going to happen in the future. But it's also important to note that most likely, and that this has been the past trend, is that this line is not going to continue straight up like this. It's going to flatten over time as we continue to, you know, add more renewables into the electrical grid, as we maybe find develop more efficient equipment, maybe as this building gets retrofitted at year 32, and better windows are installed, or more installation, whatever it is, whatever that scenario looks like, this building's going to in all likelihood consume less energy. So that's the operational part. Now, when we look at the embodied carbon, which is shown in blue, we can see it's just a flat line. It doesn't change at all throughout the life cycle of the building. But as soon as we reach occupancy, day one, as soon as this building opens up, the embodied carbon has been emitted. Like it's a sunken cost. We cannot get it back. There's nothing we can do in the future to this building to change that. So the point of that is, like, the way that we have an effect on reducing this is by designing it into the building. And so this has to be tackled on the design stage of the building. Another important factor here is that a lot of countries have signed on to the Paris Agreement. There's a lot of organizations that have ESG policies where we're trying to reduce, maybe reach net zero by 2035, 2030, 2050 in some cases, whatever the scenario is. For these organizations that are trying to hit those, let's say, 2030 goals, 2030 is not very far away. It's like 7 years away, right? So when we look at this yellowed out area and we see, like, let's say this is 2030, the ratio between the operating emissions and the embodied emissions is heavily weighted towards the embodied carbon side of the picture. So if we want to have the biggest impact by that time frame, this is our low-hanging fruit. This is where we need to be putting our attention to. Of course, like, by the time we get to the end of the building life cycle, as I mentioned, like in North America, this ratio is about 50-50. As I said, this is a bit of an older chart. So, you know, our current statistics show that that this ratio is about 50-50 currently. these three charts here are basically the same as what we were just looking at, the red and the blue one. They just show a little bit more specific information. So starting with, again, I know I'm speaking to an international audience, and I'm showing you a lot of Canadian data, but this is what I have, and I think it represents the picture fairly well. So we're going to focus on the city of Vancouver here and the city of Calgary, where I actually live. So in Calgary, most of the electricity is much of it is still coming from coal, and what's not coming from coal is largely a lot of our coal plants have been converted to natural gas, and there is some renewable, of course, and that's increasing. But basically, the current state of affairs is that most of the electricity is still coming from coal. So it's a relatively dirty energy grid. So when we look at, like, all three of these buildings are the same. They're high performance buildings. They're all designed the same. They have the same embodied carbon, which is shown in the light green. But when we look at the dark gray, just based on, there are a couple of factors here, but because of the dirty energy grid, the building in Calgary has a significantly higher operating emissions than the one in Vancouver, where it's mostly hydroelectric power. There are a couple of other factors as well that play into this. For example, Calgary gets very cold in the winter. If anybody's familiar with Canada, you've probably heard it gets pretty chilly here in the winter time. Vancouver, not so much. It's actually a pretty temperate climate. It rarely gets below freezing, which is a kind of a Canadian anomaly. So that's another factor that plays into this. But this is why it's important for us to look at the whole life cycle of the building. As important as I was mentioning in the previous slide, as important as it is for us to be talking about embodied carbon, and if we want to have the biggest impact immediately, that's really where our low-hanging fruit is. We don't want to throw the baby out with the bathwater. It's also important for us to be paying attention to the operational side of things as well, and getting a sense of how do we play with these different levers. An example that I like to give in this scenario is if we were to look at changing the windows in this building from double pane to triple pane windows, we know that our operating, or I should say, we know that our embodied carbon emissions are going to go up because there's more materials, there's more glass, it's a heavier product that needs to be shipped. So the embodied carbon in that product is going to be higher, meaning that the building is going to have higher embodied carbon. But it's going to reduce the operating energy consumption as well. But based on the location and based on the local energy grid, how is this building being powered? We need to look at, does the increase in embodied carbon from the windows offset the operating emissions enough for it to make sense for us to make this decision? And the answer is, I don't know. We have to do this analysis on every building, every location, to actually be able to get a sense of this. This slide just kind of shows a little bit more about what I was talking about earlier, where currently we've got 2/3. So the gray is operating carbon emissions, and then the green is embodied carbon emissions. And currently, globally, we have 2/3, 1/3, 2/3 operating carbon emissions and 1/3 embodied. But as we continue to decarbonize that energy grid, if the embodied carbon stays the same, it just takes up more and more of the picture as we reduce our operating emissions. So as time goes by, it's just going to become a bigger and bigger piece of the picture. So there's a couple of things I want to say about this slide. I won't spend a lot of time here, but this is the slide I was looking for earlier. It's kind of in the wrong place, so I apologize for that. But when we were talking about the total global emissions, like our entire global emissions on an annual basis, what the scientific community on climate change has determined is an approximate estimate of how much carbon basically we can emit for us to stay within a certain within a reasonable temperature range for us to be able to continue to survive. Really, is what the biggest concern is here, and so I liken this to kind of like a bank account. If we have let's say $1,000 or €1,000 available in our account, and we have to survive for 10 months on this, we can break that average into, well, okay, we have $100 a month to spend, but if we're spending $250 a month, that first month that we spend, the following 9 months, we have substantially less than $100 per month to spend. And if we spend 250 again the following month, that we've got basically 500 left that has to last us the 8 remaining months. And that's basically how we're looking at this climate change scenario, where as every year that we continue to emit the same amount of emissions, which is way too high, we just have less available room to be able to keep us within this safe temperature range. And like, we haven't even hit 1.5 global average yet, and open up the news and we can see some of the stuff that's happening around the world. So these are real issues that just need to be tackled. And luckily for us, we're in a good position to, like everybody on this call, we are in a good position to be able to make some significant impacts to this. So we're gonna dig into this a little bit. Again, I'm just kind of harping on this one a little bit, but this is just maybe another way, if any of the previous slides didn't quite make sense how I was describing it. If we, like, going back to the red and the blue chart that I was showing, this is just kind of a different way to visualize that, where this vertical dotted line here, just before where this guy is standing, this is our operational, or I should say, this is our building occupancy. And before that, this is, like, let's call this 50% on each side. Actually, it says, okay, it is 50-50 there. So it takes, let's say, 5 years to extract the raw materials, transport everything, manufacture everything that's going to go into this building. And those emissions are really just this huge spike, and it's compressed into a small amount of time. And once we've occupied this building, then our operating emissions just gradually accumulate throughout the life cycle of the building until we reach the end of life, when we demolish the building, we shut it down, decommission, and then demolish the building and do whatever we do with the materials at the end of the life. So how can we help? There's I'm not sure how well in North America and Europe there's huge drives for recycling. As a company, we have a policy for not eating meat as much as we can, especially on company trips and things like that. We drive as little as we can. We take public transit or bicycle, or we minimize the amount of time that we're doing these things. And as an individual, these things do have an impact, of course, but as designers, you have the opportunity to provide, for every building that you design, like, there's potentially 2,500 tons of CO2 on an annual basis. That we have control over. So, whether we make that bigger or whether we make that smaller is totally up to us. A couple of additional visualizations that help to show how big of an impact this is. This is kind of like when we look at, this is the solar system. This is, the size of Earth compared to the sun, and the sun compared to some of the neighboring stars. This is what and this is UK based, I should point that out as well. But this is our the average individual UK citizen in comparison to the average global citizen, just around the world. And just expanding this to like what the company that you work for are going to work for, what their emissions are, and in relationship to you, and what they're doing for you, just to be able to keep you as an employee. And what do we design at work? This is just a small 10-meter square extension versus a fairly large project. And this is just a huge impact, and we all have our hands on this. And again, like I said, it's up to us whether this gets bigger or smaller. So what we do at work matters. So this is kind of the plan. So far things are not going according to this plan, but this is the intentions for reduction of carbon emissions, and it's kind of an inverted chart, so it's going up to zero, which is kind of an interesting approach. But on the left here, we're going to see some more charts like this once we get into the software. And basically, this is a benchmarking tool. So ultimately, what we want to be doing is seeing how we're, so we can get a sense of how our buildings are in comparison to other similar types of buildings, and having good tools that have a good database, and we're able to actually benchmark other products that we're putting into the building, or buildings in their entirety, and actually do comparisons against each other. So let's see. So what is a life cycle assessment? It's an ISO defined process. So basically what we're doing is it's a quantitative, I'll just read this off for you. It's a quantitative method for assessing the environmental impact associated with some or all of the life cycle stages of a building or a building product. So that gets a little bit confusing, because we have product LCA and we have building LCA. Most of what we're going to be talking about today is building LCA, but it's important for you to understand where it all begins, and that's in the products. So going back to the life cycle stages that we talked about, where we're looking at the raw material extraction, transportation, and manufacturing. Within that, we are modeling, we're basically breaking every single hand that touches the product, or really I should say every company. We need to go to those and figure out, like, what is the carbon emissions, what are the carbon emissions that are associated with say 1 square meter or 1 cubic meter of this product, or 1 kilogram of this product. And that's that number gets transferred forward to the next stage of manufacture. So if we're talking about transportation, what are the carbon emissions, per kilogram of this product? It might be, if we're talking about a very light product, like let's say an insulation, the transportation emissions might actually be higher, because they take up a substantial amount of space for the mass that they have. So so all of these things have an impact on the final emissions per, let's call it, per kilogram of a particular product that then gets installed into our buildings. So when we are looking at products that we're considering installing into our buildings, we want to assess what the final emissions are on that product, but how that number was determined was through a life cycle assessment for that product. And then we are just taking that process and using it on a larger scale by applying that to a number of different products, and then basically multiplying it, since if we're talking about that single product, with X kilograms of CO2 per kilogram of that product. We just figure out how much of that product, how many kilograms are going into the building, and multiply it by the CO2 equivalent for that. But we do have to follow the ISO and the EN standards to make sure that this process really maintains its integrity, because there's trust, as I'm sure you're all aware, is not the highest when we're talking about the sustainability industry. There's a lot of greenwashing and challenges with this space. So we want to make sure that we are operating with the most transparency and the most really just the most integrity that we can, and just trying to keep that level of trust as high as possible. Okay. This is another table showing the life cycle stages. We touched on this earlier when we were just looking at the the embodied carbon side of the life cycle stages. So this one actually shows all of them for building LCA. If we're talking about infrastructure or certain certification schemes, some of them are sometimes this changes a little bit, but generally speaking, this is what you're going to see. So again, we have our A1 to A3, and that information is typically going to be found in the product information, and we're going to explore that a little bit, what product information is and what that looks like. So basically everything that's outside of the red checked box and the yellow, that would be considered our embodied carbon. In an ideal world, we're modeling all of this stuff. In a lot of cases, we're not getting, say, A5, for example, our construction site operations, things like that. But you know, this is improving as more and more people are becoming familiar with actually performing this work. So. The B6 and B7 that's highlighted in red here, or I should say boxed in red, that is our operating emissions. So they do have a category in the life cycle stages, which is important. So going back to that analogy that I mentioned earlier, where we are looking at replacing double pane windows with triple pane windows, this feature, this function of being able to perform determine what the operational energy emissions and the operational water emissions, water use emissions are. This is really important to be able to see what happens if we turn this lever. How does that affect other parts of the building? And the more information, the more data that we're inputting into our models, the better decisions we're going to be able to make to really have a big impact. And then D, I haven't talked about D yet. This is really benefits and deficits, anything outside of the system boundary. So the system boundary is the basically our project scope and everything that falls within that scope, and yeah, whether that's operational or embodied emissions, it's really just everything that falls within our call it our site boundary, or sometimes the building boundary, wherever that is. D, just a simple example for D would be, let's say we put solar panels on the roof of this project. So the solar panels themselves and the operation of the panels are going to affect our embodied carbon and our operational carbon within the system boundary. But if those panels are generating excess power and delivering that power into the grid, that falls outside, that excess power falls outside of the system boundary. So that would be that would be one example of something that can fall outside. So I will continue on from here. Yeah, so again, just because I know it can be complicated, I've got a couple more visualizations here that just kind of help understand the balance and how embodied carbon and operating carbon relate to each other. So this is just kind of the cycle where we've got project inception and design. Basically, once we start getting materials manufactured and delivered, we've got our A1 through A5, and basically this line here, this horizontal line, practical completion, that's when the building reaches occupancy. And then at the end of the life, once we've decommissioned the building and shut it down, then of course we demolish and deconstruct. We have to transport this stuff. We have to process the waste, and then ideally we're reusing, recycling these products as well. Oftentimes, like it's shown as dephase here. So let's say some of these, some of the waste material is going to an incinerator, or a waste I should say like a waste recapture site. So there's obviously going to be carbon emissions related to the incineration of that product, but there will also be power that's generated as well. So those are both scenarios that get calculated, and we want to be able to account for those. And then, of course, on the operational side of things, from our practical completion, as soon as we reach occupancy, we're using energy and water, and basically this is the next, say, 50, 60, 100 years of this building's life cycle, until we reach the end of life and we decommission and shut it down. This is both sides of the picture together, and this is we do have tools, and we talk a lot about circular economy, and this is really what it comes down to. We want to make sure that we're designing to be reusing as much of this stuff as possible, and just really minimizing the waste products that we're finishing with. I mentioned earlier that we are going to talk about product documentation, or product data. So here's a term you're going to get really familiar with when we're talking about life cycle assessment, and that's environmental product declaration, or EPDs. And really what the EPD is, an easy way to understand this, it's kind of like a specification document that shows what the environmental impact of a product is. That's really the best way to look at it. So, and we're going to be looking at a number of EPDs once we start getting into the LCAs. And really, the EPD is kind of the backbone of a building LCA. So for for us to be able to perform a good quality building LCA, we need to have good quality EPD data. The more general and generic the EPD data is, the less focused our building LCA is, and the less the less really information we have to make good decisions is possible. So we believe that it's really important to have very specific EPD data for a specific product from a specific manufacturer, and use that as much as possible. Of course, that's not always available, or there are scenarios where we do want to use that general data, the generic data we call it. We'll get into that. But ideally, we do want to be using specific product information. So I just used a couple of these terminologies. I guess I explained this in a non-direct way, but the different types of EPDs are generic, as I mentioned. So these are industry averages. They're often produced by trade organizations, or sometimes governments. Sometimes we produce this information at One Click LCA if it's not available. And basically what we do is we collect we collect as much information from as many different manufacturers in a specific region that we can. So, for example, in Canada, the concrete organization that we have here just went to divided Canada into 7 regions. So in most cases, it's divided by province. So they went around to the different concrete manufacturers in that province, collected as much data as they could, and then just averaged it and created an EPD related to those products. So that's basically what that is. Then we have manufacturer specific EPDs, and this is kind of what it sounds like. It's we're taking EPDs that are from a specific manufacturer, and they So again, sometimes this information is averaged across that manufacturer, but it's often product specific. Like it's usually product specific. But in certain circumstances, we have manufacturers that have multiple different facilities. So using concrete as an example, if I'll use the Calgary, Vancouver analogy again, where if we have a manufacturer that makes a specific concrete mix, and in one of them they make that mix in Vancouver, and the other one the mix is in Calgary, even though the product is identical, it's going to have a substantially different carbon footprint just because of the local energy mix and possibly transportation distances for the source materials and things like that as well. So ultimately, plant specific data is what we want to be working from. That's the best case scenario, and product specific as well from a single manufacturer. If they only have a single plant, that's great also. So ideally we want to be getting this, but sometimes we want to be modeling, hypothetical buildings and things like that. In those cases, generic information is often what we want to be using. And last but not least is private data. So with one-click LCA, in the case that, let's say there's a product that there's an ideal product that you want to use, but you haven't found it, and you want to model that, or if you have a manufacturer that hasn't produced an EPD, but you want to use their data, you can get the information from them, and create your own private data that stays within your account. We don't make it available into our broader database because it's not verified. We can't confirm that it's accurate in any way. But you are allowed to use that information. So there is private data as well. Yeah, so I did mention that we're going to talk about some of the market cases for some of the stuff. We're going to come back to this a little bit, but with basically quantifying and reducing our construction impacts or environmental impacts in construction. For the most part, we're starting to see a lot of policy around the world that's really driving this, but there are also organizational level drivers as well that I think are really important. So whether it's corporate social responsibility or ESG policies, things like this, this is really driving a lot of changes. There's also customer interest as well. There's in Canada specifically, for people, we'll say millennial generation and younger, the intent of new home buyers to pay a little bit extra for property. They're willing to pay up to 15 to 20% more in some cases for property, even though it may be smaller on a smaller property, and they're willing to do that for a more efficient, more sustainable home. It's something that's really proliferating through younger generations, and it's moving in the right direction. So this is also driving this. And then of course carbon markets, that's a murky topic for sure, but it's the fact that there is pricing being attached to carbon, which has really been an externalized cost that we're all paying these days, in some way or another. Now we're actually trying to figure out a way to internalize those costs and apply that directly to the to the products and the emissions that are associated with those. So how do we do an LCA? We're going to get into the software in a bit, but ultimately I just want to kind of give a high level overview of what it looks like and what we're trying to achieve here. So first things first, we want to assess a building. We want to figure out what's in it, and really just figure what the emissions are for this particular project. And then as we create new designs for this project, we want to be able to compare them against each other to see how big of an impact do the changes that I've made have on this project overall. And then, of course, optimization. How do we reduce our impact at the highest level? How do we just move this forward in the best way possible? And there's a few ways to do that. So generally speaking, this graphic just shows project flexibility, and basically as we proceed along the blue line. So at the beginning of the design stage of a project, we know very little about how this project is going to come together, and but we have a lot of design freedom. We can attack, we can change a lot of things. It doesn't cost a lot of money to change our minds, because really not much work has been done. But as we proceed through the design stages, as we progress along the timeline, we gain more knowledge about the project, but we also lose a lot of freedom, because it just we start getting locked into some of our decisions. A lot of time, energy, and money is often spent at this point, and so we're really losing our flexibility. So ultimately, if we can find a way to increase our design knowledge earlier on, like it's shown here, the crux of the two lines moves further up the timeline and basically reduces our costs. So learning as much about this project as soon as we can, it gives us the most flexibility that it's possible. And for anybody that's done LCA work, or if you've seen LCA work being done, typically, especially in North America, it's done way back here. Like it's done kind of as a last stage. The design of the project is done, and we're just doing an LCA to see what the impact is, just because it has to be done for a particular municipal policy or a certification of some sort, or whatever it is. So we're putting this we're doing the opposite of this, really, when we have, you know, the most design knowledge but the least freedom, and it's it basically just locked in. So the earlier we do this, the better. And this kind of shows this in a little bit more detail. So you know, we want to be starting optimizing for carbon at the strategy stage. So as soon as we're talking about this project, we really want to be looking at how do we implement, how do we design this in the best way possible? How do we change, like maybe we can change the structure, maybe we can change the size or the orientation of the building. Like there's a lot of things that we can do here. And then as we move forward into from concept and design, you know, looking at modeling different aspects of the building to you know, make it more energy efficient, and playing with some of the levers of, do we want to go double pane or triple pane windows with this building, these sorts of details. And then of course tracking the construction once we are building is important and often not done. But it's really important. We design one way. How do we know that that design is actually what's being built? And this is really the build and as built stages. So of course, tracking what's happening as we're building. If we're changing products throughout the design, often the contractors either may not be able to find a particular product that was specified, or they may have like they're not doing this modeling. They don't know what the carbon optimization intent is for this project. They see a specification for a cladding element, and they know that they can find something that's cheaper, that performs, maybe it performs better on a technical basis, but they have no idea what the carbon footprint is of that product. So making sure that we're tracking these things as the project is being built is really important. And then of course, once we're doing our as-built, running that assessment again, just to make sure that what we designed for is reflective of what the final product is. And then benchmarking at the end, of course, so that we are able to have a real assessment of what the landscape of existing building inventory looks like, so that so that we have like real data to improve on and move forward with. So starting with assess, we're going to go through these 3 steps. So there's a couple things that that are required for this. Let's just add all those in here. So we need to know what the project details are. So what is the floor area of the building, the gross floor area? Where is it? You know, is it in Calgary or is it in Vancouver? Like these are important aspects. How far do the products need to be shipped to get to the site? And then we need to do an inventory of materials. This can be done manually. It can be done from a BIM tool like Revit, something that takes determines exactly what the products are in the building and then quantifies them as well. So we need that information. We need to know what is in there and how much. And then the environmental impact data for the products, and that comes from our EPDs, which, like I said, we're going to be talking a lot about EPDs, and that's where that information comes from. And with that information, we can basically figure out what the total quantities are, figure out what the impacts of each individual product, and then we have a total environmental impact of the building. So when we see this 150 kilograms of CO2e. Again, I want to repeat what I said earlier. So basically what we have here is this. We're generally looking at this on a square meter basis in the building, but whatever, like in this one, it doesn't define that. So let's just say it's 100 kilograms of steel total in the building. It's not very much, but we're looking at the CO2 equivalent. So maybe it's not just straight CO2 emissions related to the manufacture and the delivery of that product, but we're also calculating everything else, and then and being able to chart. Well, we're going to look at some of the charts some more in a bit. So within, we're going to get into Revit a little bit. I'm not going to spend a whole lot of time in Revit, but what's important is that we can take a building model and either run our life cycle assessment within Revit. We can also export that data into the cloud, into one-click LCA's tools. And that's exactly what we're going to be doing in a few minutes here. We also have, there's also a ton of different integrations here. So, and ultimately this stuff is to make your life a lot easier. So when it comes to doing the assessment, designing the building in, say, Revit, and running your energy modeling for the building in, let's say, Design Builder, excuse me. And then being able to plug all of this data in directly into one-click just it's going to make your life a whole lot easier than it would be otherwise. You know, I'd like to say gone are the days when all of this was done manually in Excel spreadsheets. I wouldn't say those days are completely gone, but for the most part, like really what we're trying to do is streamline this as much as possible and just integrate that communication for a couple of reasons. It saves a hell of a lot of time, but it's also going to make your life a lot easier, just reduce the margin of error when inputting data and things like that. So, but of course, it's important to understand how the data is brought across. There we go. Being able to visualize the results really just helps us make better decisions. So here's an example of the Sankey diagram and how the different life cycle phases are broken out by, you know, our A1 to A3, our B4, B5 construction site operations. what part of the building these are going into, what are the materials, and then what are the basically what are the product categories that that this information is going to. This ultimately just it becomes helpful when it comes to making decisions. Again, here are some other charts. We're going to be looking at this shortly, so just breaking the information up into different categories. Bubble chart, building circularity chart. We do have a building circularity tool that that does model how much of the products, how much of the materials that are going into the building are recyclable or able to be reused with our current practices for dealing with the waste materials. Here's another visualization, just being able to see where the carbon hotspots are in a building. Usually we've got green for the light areas and red for the hotspots. These are the carbon intensive areas. And then compare our designs. So I mentioned this earlier, we're going to be looking more at this, but being able to see how each of our 3 different building designs compare against each other on global warming potential, eutrophication potential, these sorts of indicators, again, will help us make better decisions. And then benchmarking against other similar archetypes of buildings. So being able to see what our carbon emissions are per square meter for this particular design, and how that compares against other similar archetypes of buildings. So whether this is an apartment building or a single family dwelling or a hospital, whatever it is, being able to benchmark this against that. And then last one is optimization. Oops. So there's 2 ways of approaching optimization. The first thing is use less material. That's like the most important one that we can do. So there's a lot of there's some great research being done out of Ontario on this by I'm going to screw up the company name, so I'm not going to say it, but basically out of the US, the Toronto, they just changed the name too, so I'm going to screw that up as well. Sorry about that, but basically all Mass Design Group, that's what the company is. That they're doing some great research out of Ontario on different building designs and how to basically achieve lower carbon footprints on buildings just by through real world building designs that are being done. So an example would be if we've got let's say a 15-story building, and we're building this in maybe it's an area that has or we're considering purchasing some land in an area that has relatively poor soil conditions, and we know that because because of the neighboring buildings that we're going to have a very large foundation, maybe with some deep piles and things like that, and we are also intending on putting some underground parkade here. Maybe that's not the best site to be putting this project on. Maybe we can relocate that site or relocate the site to an area that has better soil conditions. Another option could be to build the building lighter instead of building the entire thing out of concrete. Can we use mass timber somewhere to lighten the building and be able to lighten the foundation? Can we get rid of the underground parkades, or at least one level of the underground parkade? These sorts of factors are going to have by far the biggest impact on our carbon emissions for this building design. Once we've locked, and that's what I was talking about, and we're going to get into some of the strategy level things. But by being able to make these decisions early on, that's when we have the most flexibility, and we can have by far the biggest impact. And then once we've locked that decision in, maybe we do decide we're going to build on this site, but we're going to get rid of both levels of parkade. We're going to use mass timber, and from there we can begin to design the building and then select more sustainable products that are going to go into the building once we do start specifying products and getting into the specifics. Yeah, here's just an example of a breakdown of different carbon emissions for building parts. Anybody who's familiar with embodied carbon, no surprise. This one, the weight is in the concrete. So usually that's the low-hanging fruit to be able to reduce the carbon emissions for our building. And then here's just a couple more charts of ways that some of this information is broken out. And yeah, let's see. Okay, so actions beyond design. So as designers, something that I often will request, or if people are asking me, like, what's the biggest thing that we can be doing as architects and engineers? And the first one is write EPDs into your specifications. Make it clear to your contractors that any product that they're looking to, usually we have like 3 specified products, and the 4th option is an approved alternative. Make sure that that 4th option, if there's going to be an approved alternative, that it has to have an EPD, and then make sure that those 3 products that you are specifying also have EPDs, and you've in a best case scenario, you've optimized for lower carbon emissions from those products. Second is demand data from your manufacturers. So as manufacturers, as manufacturers are coming to you and asking you to specify their products, you're going to get this all the time, and there'll be sales guys knocking on your door saying, "Here's our great product. It's so much better than our competitors because of X or Y. Fill in the blank." As that's happening, ask them for their EPDs, and you can just ask and be and leave it at that. And the more they hear that message, the more likely they are to understand, okay, we should actually get this done, because EPDs are a voluntary document. Or alternatively, you can say, we're not going to use this without an EPD, so go get it done. It's you can kind of draw the line in the sand as well. And then assessing your designs and share benchmarking to share your data to benchmarking databases. So that's something that happens within one click. We take care of that for you, but there are other benchmarking databases as well, and just making sure that your information of completed projects is out there, so that whether the project performs well or poorly, it gives us that's usable information that can help the next team that maybe needs to design a project in that region, or similar type of project, or maybe they're doing meta-analysis on certain ways to improve future building designs. Oh, there's a 4th one. So share your low impact design strategies with your colleagues. So kind of like what we're doing here at One Click, we do a lot of webinars, we do a lot of academy trainings and things like that. You're joining in on one right now with the team here, and just sharing ways, like clever design strategies, anything that you may have done that got you to be able to have a lower impact on your project. Quick example here, going back to Mass Design Group, they actually recently, I shouldn't say recently, I think it was more than a year ago now, but they did some research where they took 2 identical buildings, and they, just by changing some of the products in the building, they didn't change the overall design of the project. They kept the superstructure the way it was, and everything else. They just selected better products, and they did a couple of product exchanges. They selected lower carbon concrete. They changed, I think it was rock wool insulation to cellulose fiber, and made a number of changes like this, and they were able to reduce the carbon emissions by 30% or I should say the whole building emissions, carbon emissions for this project by 30%, and they were able to keep the price the same. Like, it actually, the price reduced by I think it was a couple grand or something like that. It was negligible, but they basically kept it the same. So it was pretty impressive research. So being able to share this information with other people that you're working with really just helps us all grow, because this is it's a complex space, and we just all need to get better at it. So anything that's clever or interesting that you've discovered, please share. So how does one-click LCA decarbonize the construction industry? How are we approaching this? So as I mentioned earlier, one-click is a software platform. So we don't just have a single software tool. We have a ton of different tools that are focused on in a number of different areas. That includes product manufacturers. So we help manufacturers produce their EPDs. And then we also have tools for building design, construction, infrastructure, and city planning to help optimize, buildings and infrastructure. And then once those projects are completed, we also have GHG accounting tools for companies that are looking to track their scopes 1, 2, and 3 GHG gases. So we can convert LCA data into that scope 1, 2, and 3, and go on from there. We also do we have a number of services, so we do a lot of training. This sort of thing is pretty frequent with us. We do some consulting for companies. Every once in a while, we'll develop custom tools if it's required, and we do that sort of thing. And then we've done lots of policy work, just really, I would say, around the world. We've done a ton of work in that space. I like this slide kind of breaks a lot of the rules of a good slide. There's a lot of information here. It's a little bit dense, but I like it because it shows the parallel. It shows two parallel lines, one with construction and one with manufacturing. And at every step along the design continuum, the two are drawing from each other. So whether it's from our early stage strategy tool, Carbon Designer 3D, which we're going to get into in a little bit, or all the way through to carbon strategy. We're pulling from product and EPD data, and really just trying to keep a fairly comprehensive picture at all stages, so that we're able to make the best decisions possible. This is just another visualization of a project going through its different design stages. And yeah, as I mentioned, one-click's global platform. So no matter what country you're in, we probably have, we certainly have tools available for you. We may have certifications that are specific to your country or your region. We have tools for practically every certification that's out there that relates to embodied carbon. We've got a huge database, well over 150,000 data sets. So basically that's EPDs and in some cases non-verified EPDs. If the data is not available, like we've got stuff available for practically everything. And why that's important is going back to what we were talking about earlier, where we have, if we want to get the most comprehensive picture of a project, we want to be using product data that's as specific as possible. So basically, we scrape the entire internet for new EPDs a couple of times a week. At the end, we run them through a quality check, and then if everything pans out, it gets added to our database, which feeds into our building design tools. We've got integrations for lots of stuff, Revit, IESVE, whatever it is that you're using. We've got 150 staff in house, so there's people available to help out if you need anything, and we've been around for a long time. So one click's not going anywhere. We're stalwart in the industry, and yeah, it's been a good ride. So I'm going to skip over that one. If anybody wants to read a little bit more, we've got tons of stuff on our website. I definitely encourage you to explore there. There's articles for all kinds of things. We have ebooks if you want to expand your knowledge on EPDs, for example. We've got if you end up working for a municipality, we've got guides for setting municipal policy and all sorts of stuff. So and because we've done a lot of that work, like we have some pretty good pretty good input. So yeah, please have a look. And if anybody wants to reach out to me, if you want to get in contact with me, this is my info, email, phone, whatever. I'm usually available. So yeah, feel free to reach out anytime. So I guess before I jump into the software, I'm going to stop sharing my screen for a minute and open this up for questions, because I know I covered a lot of ground there, and just want to answer anything that maybe wasn't clear before we start delving into software tools.
Thanks again, Travis, for having your holiday, actually, sharing it with us. And it was very insightful presentation, at least for me. And the results is all clear, and you explain it everything perfectly. There was a moment I wanted to jump in your conversation and say, just take a break and take a water, but you do it
That's
perfectly.
what I'm doing right now. If anybody needs a breather, maybe we take a couple minutes here, just 2 or 3. Because I do still have a lot of content that we do that I want to get through. So yeah, but I guess were there any questions, Iman? I see a little bit in the chat here. Let me just
no, everything is clear and great.
Awesome.
Just one question from my side. Is there any, I see there are IFC integration, but and GBXML integration, but I was curious, do you integrate OSM data that come from Energy Plus or OpenStudio, because they have layers of construction, it's all written out, the areas are there, and I don't see in your integration platforms, but that was a question from my side, actually.
Yeah, totally. That's a great question. I don't believe we do currently have integration for those, but what we do have is because there are so many softwares out there, we're not going to integrate with everything. But practically everything you can export from into Excel. So in the case that we don't have an integration, you're working with a tool that doesn't integrate with with that. Oh yeah, it looks like the student license just came through as well. Yeah, so if there's ever a case that there's not an integration, you can always export the data into Excel, and then from there import the Excel spreadsheet into one click. Yeah, that's always an option. It's an extra step, a little bit of a pain in the ass, but it's always available. Great. So is that all, Iman?
Yeah, great. Thank you for your information.
Cool. All right, I'm gonna move forward because I know that took a lot longer than I was actually expecting. So let's plow forward, and because we've got an hour left, and yeah, so let's get to it. So while my screen loads, there we go. Okay, so what you're looking at right now is when you first log into OneClick. So if you just go to our website and log in, you can create an account. It's free, but you'll also be getting a student license. I think Shaggy just shared the link for that. I just saw a message come through. I actually was going to apologize earlier. I made a mistake when I put a request through to our support team to get that license, and it wasn't ready for for earlier. But yeah, it looks like that did. Okay, there's a couple of comments there I'll read later, but you will be getting a training license available by tomorrow at the latest, and that will give you access to a couple of the tools that we're going to be looking at. So basically, once you sign into the website, it's going to take you to this main dashboard. And from here, there's always some news on top, like new tools that we've released, or if there's training courses that are coming up, that sort of thing. You'll find this information at the top. You can also organize your projects by folders. These are just the default folders. You can customize these however you like. I've just left everything kind of floating on my desktop because it's kind of how I roll. So these are the projects that are linked to my account and that I have access to. So we could go into any one of these, but what we're actually going to do today is we're going to create a new project. So I'm just going to go to add. We're going to add a new building. And we need to link this to our license. So I'll link it to our demo license. You're going to have another one. It should be the only one that's available there anyways. And then we need to give our project a name. So I'm just going to call this one July 23rd demo. We can organize by folder, or we can leave it on the main page. I'm going to leave that on the main page. And then we need to select our building archetype. So what type of building is this? Is it an apartment building or a hospital or a single family dwelling? This is for our benchmarking tool. So this is where it's basically drawing that information from and creating that or I should say, giving us the information for the benchmarking. So for this one, I'm just going to go with we'll go with an office building. I'm going to leave this one in Canada. We can select our province or state as well, or depending on what country you're in. It may be divided by state. It may just be the country, and then we can put our address in here as well for identification purposes. Next, we have some optional information here. Basically, this is where we can manually enter our gross floor area, number of above ground floors, and so on. But this information is going to come later, so I'm just going to skip this. Now we are at the project dashboard, not to be confused with the main dashboard. So from here, this is where we're going to keep coming back to this page, and there's going to be more information each time we do. But right now it's blank because we haven't given it anything to work with. So, so I'm just going to click on Get Started here, and we need to select which tools we're using to perform our work here. So, so for, I think what we're going to be doing is the Lifecycle Carbon tool, Global. And I'm also going to select the Net Zero Carbon tool as well, just so we can have another tool to look at. You're not going to have all of these available. As I mentioned, there's dozens here, but whatever your certification scheme that you're going for is, we have stuff in here for it. But if you're in our case, we're just running a straight life cycle assessment, and but we want to be including all of the life cycle stages in it. So I'm going to click on next, and we need to give our first design a name. I'm going to call this one our baseline since it's our first one. And I'll keep both of our tools selected here and move on to the next step. Oh, actually, I should show this as well. If we wanted to separate this as, say, like this is our early stage strategy design, we can, which it actually is. So I'm actually going to select that. Or if we're at a later stage, this just helps us keep our project organized as we progress through multiple different designs. And then next, I'm going to go with our default LCA parameters. We can make a lot of adjustments on the back end as well, but to keep it easy to use in our case, I'm going to leave this at our defaults. Just give that a second to load. So what we have here, now that we're back at the project dashboard, is we now have a couple of tools available here. So the life cycle carbon and the net zero carbon tool that we selected. And then we have our initial design, our baseline design. So generally speaking, especially since this is a strategy level, the strategy level stage of our project, we're just getting into this. We're going to open up the Carbon Designer 3D tool, and we're going to basically create a building model just like we would in Revit. And it's like we have no information about this project. We don't know a lot of information about this project so far. Maybe we know that it has to be 10,000 square meters, and we know our site size, or our approximate site size, and we know that we want a little bit of underground parkade, and that maybe that's all we know. So so we can actually design a building based on that information and get and run an LCA on that building. So it's a separate software. We're going to go into this, and I'll go into the lifecycle carbon tool. I'll set it for that one, and we'll do most of our work there. So this is the Carbon Designer 3D tool. It's pretty straightforward. It's designed to be very easy to use. We're going to basically create a building in 10 minutes or so. If you're going to do this properly, you may want to spend half a day or maybe a day or something, depending on how complex the building is, or at least a couple hours. And just fine tuning this and making sure that it does fit exactly what you want to be doing. But it's also designed to be very quick, very fast, and easy. So we're not actually doing a lot of the schematic design in, say, Revit or other tools that can take substantially more time. So we want to be able to make quick designs here. So we're going to create a new project, or I should say a new design. So within this, I'm actually going to call this, we'll call this one our carbon model. I'm going to leave this one at our default ASHRAE zones. So depending on where in the world you are, it's going to be referencing local environmental zones, or I should say climate zones. We want our gross floor area. We said 10,000 square meters, and I'm going to leave this at 50 years for a calculation period. We'll go next. And I'd set this project as an office building, so we're going to leave that. Again, this is selecting our building archetypes. This helps us it's works similar to the benchmarking tool, except in reverse. So since this is a hypothetical building, it's taking other similar types of buildings and creating an average of the footprint of those buildings with those types of assemblies as well, and creating a building model based on those. So I'll select our office building and move to the next step. We need to define our scope here. So we're going to include all the building parts here. Let's say we don't know how many floors we want above ground. We want to actually look at a couple of different scenarios. So we're going to start with an 8-story, and we had two levels of underground parkade. So we've got some unheated floors. There's no usable space underground, so I'm going to leave that. We can also select our structural frames here. So if we want cast in place concrete, precast concrete, steel frame, mass timber, we've got a few different options here. But in this case, I'm just going to leave it at the default for now. We can make some additional changes to that at a later stage. So and if we wanted to, this is just for visualization, but if we wanted to show piles as well, let's say there's 8 meters long. And we can include for that as also, and then some soil stabilization as well. And go to the next stage. Um, so as you can see, we already have a 3D model of this building that's basically done. If you're speaking with anybody who's not technical, this is really helpful just to be able to visualize things and talk about different aspects of it. Um, so we can add a little bit more specifics about the building geometry here. So if we know what the floor thickness is, for example, or we want to change the height between our floors, we can make these adjustments. Let's say we know what like there's a building code, we can't build over a certain height. We can make sure that we're sticking within that maximum elevation limit, and we can make changes here. There are a few elements that are locked in here. So like, for example, the shape efficiency factor, this building is being shown as a shoebox, but we know that that's rarely the actual design. So there's a bit of an allowance here for loss of efficiency with the shape of the building. If you know for a fact that this is going to be a building with a fairly complex shape, you can always reach out to our support team and ask them to make a change to this. But as it stands right now, this is locked in. And any of these other ones that are not, I can't highlight these. These can be adjusted as well. You just need to reach out to our support team to make those adjustments. Now there's a little bit of extra information here. So with our building structures, let's say, like I said, we know that this is on poor soil conditions. So maybe we can add an allowance for our foundations just to make sure that we're accounting for that. Or we know that there are additional balconies, additional staircases, whatever it is, we can make those types of adjustments here. And next, we need to choose a template. So for my account, I only have our default template set up here. But what you can do is create custom templates that are based on, let's say there are common building designs that you generally use. Or if there's a past project that you want to be modeling this building off of, you can create templates from other designs and things like that, and then apply those to this as well. So it's basically, I don't want to say copying, but taking elements from other designs and applying it to this design. Now we're going to submit it. Now what it's doing is it's running the LCA on this project and breaking it into its different components. So we're still working within Carbon Designer, so we're not exporting this over to one-click LCA just yet, but we are still getting some LCA information. Sometimes this one just takes a little bit to load. Mine's been taking a little while to load lately, so could just be my account, or maybe it's my connection. So here we are. We have, again, our 3D model, which can be, if we want to see where our carbon hotspots are, we can activate the carbon view, and we can see where, so it shows our floor slabs are where our most carbon intensity is. We also have this chart over on the left where the carbon emissions are broken out by the different elements. So the visualization is nice, but if we want to see it in the chart as well, we can see our floor slabs are the bigger emitter here. So really that if we want to make changes to this, we can focus on our ventilation, heat distribution, electrification as well, and really just tackle these higher emitting elements of the building. And where we do that, there's a few ways of doing that, but the easiest way is scrolling down here. We can actually go and find our floor slabs. And actually what I'm going to do, let me go back up to the top. Oops. computer's overheating. Okay, so first, because we want to keep a snapshot of this, or I want to keep a snapshot of this, I'm going to create a copy of this design. And I'll be creative and leave the name of this copy of carbon model. So now we have a duplicate of this design, and any changes that we make to this one will be reflected in our chart here. So if I scroll down and go and find our floor slabs, show unused resources, we can change the floor assembly to, actually, I'll edit floor slabs. So let's say some of this, I know maybe we're in a seismic area or whatever. Let's say I know that 10% of my slabs need to stay as cast in place with our original design here. And we would never do this, but I don't think we would use a wooden floor joist in a building like this, but let's just do it for the sake of this. So the other 90% of our floor slabs are going to be wooden floor joist assemblies, and I'll finish editing. We also have, there are plenty of choices here. There's various different concrete, composites, steel, whatever, mass timber, CLT. There are a bunch of different options here. If there's something that you're actually using that isn't available here, you can also create your own private constructions with a lot of the accounts and create your own assemblies here to that you can use in this. So if I scroll back up to the top, and okay, so it should show our floor slabs have on our copy design is quite a bit lower than our original design. So we can actually fairly quickly go through each stage of this project. That was super easy. Like didn't take a whole lot of work or effort. We didn't have to adjust any drawings or anything like that. We just shifted that single element, and we can see how big of an impact that has on this project. So let's say we're happy with that, and we can, well, before I move on, we can create multiple new designs. So with this, in this case, I just created a copy of our original design, but if we wanted to go through and say, okay, so that's what our 8-story building with 2 underground parkades looks like, or two stories of underground parkade. What happens if we remove the parkade entirely and we change the dimensions of the building and make it 12 stories? We can do that as well. And then again, completely change the structure, the superstructure, and see, we can add up to 4 designs within here and do these really quick and easy modifications and improvements and optimization to this design. And going back to that chart that I was showing earlier, where this is when we have the most design flexibility and we know the least about the project, but this will help us gain a high level of knowledge from a carbon perspective of the project. There's a concept that that's used a lot called value engineering, and this usually with value engineering, we're bringing we're trying to get as much information on the front end of the project as possible to find ways to cut costs, to find more cost-effective ways of doing things. This is value engineering from a carbon perspective. So how can we have the biggest impact on the carbon footprint of this project and do it before we've spent any money on the design of this? So that's what this tool is designed for. So assuming that we're happy with the second design, let's see, just want to make sure I select the right one. Get so we're going to save this design to our project. So just like in Revit, we're going to go through this same process when we export from Revit, but we need to choose a design that we're importing to. So I'm going to choose our baseline design, and we can either overwrite existing data or merge with existing data. So in the case that, let's say this is a 2-tiered building that has like 1 foot, building footprint or foundation footprint on the lower half, and then maybe there's like an additional 10 stories of tower above it that has you know, a little bit of a different area. We can actually merge different designs of the building together to get a sense of what that project will look like from a carbon perspective. So I'm just going to save this, and now it's going to take us back to one-click LCA's LCA tools. Just give it a second to load. Okay, so when I go to our baseline design and I click our drop-down menu here, we can see now our building materials have been entered, but I still need to manually enter our calculation period and our building area. So I'm just going to go to those quickly. And I'll enter this. So I think we said 50 years and 10,000 square meters. Both are Rick's definition. 10,000. So now if I go back to our project dashboard, we're going to see a whole lot more information now. So one click now has all the information that it needs to run the LCA within here. So if I click on the drop-down menu again, we can see as before, our building materials are checked, our calculation period is now checked, and our building area is checked. So these three components are required for one-click LCA to run the LCA. The other options here, so construction site operations, going back to our life cycle phases, that's A5. Water and energy consumption, that's B6 and 7. You can see that these are optional, they're not required, but we can go in and either manually enter information there, or we can import that data from another tool. So that's available as well. If we wanted to import this data from Excel, we can do that as well. Or I'm sorry, if we wanted to add an Excel spreadsheet, we would do that here. But I'll show you another place where we'll be able to get Excel data from a Revit model. But as you can see, we've got like the benchmarking information here on the design that we've already done. It's broken out by life cycle stage in a couple of different ways here. And then we've got a chart at the bottom that's just showing global warming potential and biogenic carbon storage. And biogenic carbon storage being the carbon that's sequestered in, let's say, wood. And since we did put some wood in here, we've got a little bit of carbon sequestration. Just like we did in the Carbon Designer 3D tool, we can create a copy of this design. So I'm just going to do that. Leave it as copy of design. So if we wanted to actually go into the materials query of this, the more specifics of the materials in this design, we can do that. And then now, as you can see in the chart, we have a second bar on our bar chart, and as we make changes to the materials in this design, it will reflect here as well as in our results, which we'll take a look at in a minute, and we'll be able to see how any of the changes that we've made are affecting this in comparison to the original design. So this is where we get into the comparison of the tools. Let's see. So from here, we are going to get into the building materials as well, but I'm going to take you that after we go through Revit. But I do want to show you the results page. From here, again, we can see the Carbon Heroes benchmark tool, but I'm going to hide that. We can see the life cycle phases are broken out here, and we can see what our emissions are for each life cycle phase. And sorry, excuse me for just a second. So the different life cycle phases, like as we add more data, like if we are going to be importing, let's say an IESVE model, it's going to add a lot of our like our energy consumption and water use and that sort of thing. If we put solar panels on, let's say, we've got because we've got a lot of wood in here, we've got negative impacts on the D phase at the end of life. And this will all be adjusted as we make changes to the design. There's a completeness and plausibility checker. I think this is a really important feature, especially like the Revit models that I'm using. I'm going to show you this again when we get there, and you'll find that the Revit models have quite a lot of errors in them because I'm just using the dummy ones from Autodesk. I have one where there's a 1-inch steel plate on the roof for some reason. It took me a while to find that one, but there are just a few things that don't make sense in the design. And if the point that I'm trying to make is that if there are any errors in the design that you make, this is an opportunity where it's going to show, like, if I just import a structural model like we're going to, it's going to say, hey, there's no glass in this building. Are you sure there's no glass? And maybe there's a good reason for it, because it's just a structural model and there's no glass yet. So I can actually click this, say it's validated. I've confirmed that that's okay, and we can move on. But this is basically just a quality check to make sure that that any materials that fall outside of the threshold of what we would expect, it's flagging that for you and saying double check this and make sure that that it's supposed to be like this. We also have most contributing materials, and I love this feature. I think this is one of the most important ones in the tool, in my opinion, just because it shows you where your low-hanging fruit is. We can see that this particular concrete mix is contributing to 12% of the emissions for this building. So what this means is that if we find a better product for this, or if we can figure out a way to reduce the amount of concrete that we're using for this particular element, we can have the biggest impact on our overall carbon emissions for this project. So that's ultimately what this allows you to do. Another thing that you've probably noticed is these colored clouds here. And basically what these are is our product benchmarking. So if I click this little question mark, let's see what comes up here. Okay, so I'm going to use a different example. I'll explain why in a minute. Let's see. I'm going to go with this one, I think. Nope. Let's try this concrete. Okay, so because the because of the way that this model was generated, it's using a lot of generic data. What I'm looking for is a specific EPD. So there we go. Okay, so, and I'll go back and explain why. So from here, we can actually see the specific EPD data. If we want to just download this, it'll pop it open and we can read the actual EPD. This one's from UL, and basically for an EPD to be called an EPD, it has to have certain elements in it. So you're going to find a lot of the same information in most of these. But UL has a specific format for these. ASTM has another format. EPD Hub has another format. They can be a pain in the ass to read and compare side by side. Anybody who's done that hates it. So what we've done is we've scraped all of that information out of that EPD, and we've put it into this standard format data card. So basically all the key pieces of information are here, and it just gives us a way to if we had 3 different EPDs open, we can put them side by side and easily do comparisons on these. And with the color-coded clouds, we also have benchmarked the individual products against each other. So we found similar types of products. So I'm going to talk about CML in this case. We'll just stick with this for the moment. So there's 129 other window products that are similar to this one. And this one ranks 61 out of that total group, which earns it kind of like the light green cloud. If it were in the top fifth, we've divided it into 5 different categories or quintiles. If it were in the top fifth, it would get a dark green cloud. If it were in the worst grouping, it would get like a red cloud like this one. We're just for the sake of time, I'm not going to go into the ranking, but if we want to see what the full list of comparable products are, we can go and open this up here. But there are a couple of other ways to do that as well. I just want to make sure we have time to get to that. So there's a bunch of different charts here. However you want to be showcasing this information, there's bubble charts, pie charts, Sankey diagram, which we've seen a few times. If you want to download this as a PDF or PNG, however you want to use these images, you can do that, or you can download this in Excel as well and create your own information. It's your data. You can do whatever you want with it. So here we are. Now, if we go back to our project dashboard, let's say from here we've made some decisions on our design, and we want to go and design our project in Revit. So I'm going to pop open Revit here, and we've done our structural model. We're happy with this design so far. So we have a plugin that works directly within Revit. We can just click on one-click LCA, and we can pop open the data or the control center here. Just give it a second to load. So from here, we can do quite a lot of work. We can isolate elements in here. We can attach specific EPDs to specific elements within our design. One click automatically does this in most cases, but a lot of the time you're not going to be being that specific with the product that you're using or that you're designing in Revit. Like a lot of the time, there are a lot of places in here where it just says concrete. But if we said, let's say Heidelberg concrete, that's 35 MPa with 25% recycled content and 30% fly ash, that's very different information. So one click will go and find the specific EPD that matches that product if that information is there. If it's not, it's going to go and find the closest alternative that it can, or the best generic that it can, and it'll link the EPD to that. And but we can override that all from within Revit here. We can go into our materials, and we can link different material elements. We can actually run our results and see what the results are based on this particular design. Instead, what I'm going to do in this case is I'm going to export our data into one click. So just going to go LCA in cloud, and it's just saying anything you've highlighted is going to be unhighlighted. And now we go to the import data page. So just like we did in Carbon Designer, first thing we need to do is select a project that we're adding this to. So July 23 demo. We're going to, we can add this to we can add or overwrite this to one of our existing designs, but I'm going to create a new design for this one. We're going to stick with the Lifecycle Carbon tool. And again, just like before, if we want to add this to existing data, we can do that, or if we want to overwrite it. In this case, it doesn't matter because there's no data in this particular design yet. So we will go continue. But first, before I do that, I did promise I was going to show you this. So in the event that, let's say you're not working with Revit, you can get this data exported from Revit, and we can just take the Excel data and input it into one click as well. So basically what this shows is just need to move this over. Our first 4 columns here. So all of this information is important, but there we go. The first 4 columns are what are necessary. So the basically we need the class of material, so that the algorithm in one click can identify what the product is. We need the name of the material. So this is where it gets specific and it can identify, you know, like I said, we've got cast in place concrete 35 MPa. So in this case, because I've set my project in Canada, it's going to find me, generally speaking, it's going to find me Canadian 35 MPa generic concrete EPDs. Again, if I were more specific about this, it's going to be more specific. But you know, here it just says cast in place concrete, so it's going to find me, you know, a not ideal generic EPD, but at least it is going to find something that works in that case. We've got our quantity and unit of measurement. So we need to know how much of this stuff there is once it does link with the EPD. So so that's basically what's in the Excel spreadsheet. Oftentimes the data that you're exporting from whatever software you're using may not be formatted the same way. So you might have to do a little bit of work just reformatting it. You can always get templates from our website as well. We have templates for all of the import documents. So if you want to do it that way, that's always an option also. So yeah, just however you want to do it, that there's potential there. So no, I'm not going to say this. We'll go back to our import data page. So we've selected our project. We've stated it's a new design. We've chosen the LCA tool that we're going to use, and we're going to continue. The next stage, oh, we need to give this design a name. Let's call this one Revit, since I'm feeling creative today. And I'm going to import this to both our Lifecycle Carbon tool and the Net Zero Carbon tool. So now what it's doing is it's taking us to a page where it's asking us, how do we want to combine data points or similar data points? So in this design, as an example, there's lots of columns. So, and a lot of them are identical to each other. So instead of creating a separate line item for each of them, it's going to bulk them together and just give us a single line item so that it's easy to work with. If we want to split that, however we want to do it, we can do that. Those are options, but the intent of this is to speed up our whole process and just make things easier to work with. So I'm going to leave that at the defaults. We'll continue. Now what it's doing is it's taking each of those line items that we saw in the Excel spreadsheet and linking those with EPDs from our database. And the best EPDs that it's able to find based on the information. So in this case, great, we're successful. 100% of the data was identified. If this were an architectural model, often what happens is, like, there might be a water glass on a table, things like that. It's not able to identify those, or if there's like people in the drawing, those sorts of things, like it's not able to pick those up. So those will show up as unidentified data. Or if there's, you know, legitimate things as well that maybe you need to look at and find an appropriate EPD alternative. But what we do want to do is go through each of these line items and make sure that for this 28 MPa concrete, that this is actually the EPD that I want linked to this. So let me just click the little question mark. By the way, the little question mark is always going to bring up our EPDs. So in this case, it looks like, okay, so it linked me with a Finnish EPD. I'm in Canada, so I don't want to be using a Finnish concrete mix. So in this case, I will go, I can actually filter by, let's say, ready mix concrete. And I'm just going to leave that one bulk, and we'll go by Canada. And we can also filter by, if we wanted to filter by data source, we can do that, but I want to draw from all of them. We can filter by type. So again, just a review of the different types of EPDs. We've got generic, we have manufacturer or product specific, plant specific, and then private EPDs as well. So we can filter by those, but I'm going to leave that blank so it's collecting all of it. And if we wanted to filter by, the carbon emissions of this particular product, we could. For whatever reason, I wanted to pick the worst performing ones, I can do that. And now when I click the drop down menu, it's going to filter by what's available in. I've got the CML database selected here, I believe, which is why it's showing me this. Let me try this. Yeah, I think that's why it's doing it. So anyway, so we will go with this particular mix, and I'm gonna select for all of them. And now next time I do an import, anytime I run into a 28 MPa concrete mix, this is the EPD that it's going to default link to. It's not going to give me finished data anymore. So and I can go through each of these products, and you only have to do this the first time, really, unless you're specifically calling for a different product for this particular project, then of course you can do that. But this is a chance to select better materials. There is another place we can do this as well that we're going to get into in a minute. So I'm going to assume that we're happy with all of this, and we're going to continue. And now it's plugging all of this data into our LCA. So we're back to the results page, and it's flagged saying that I'm missing some information. So it's taken the building area from the Revit model, and it's taken all of the materials and their quantities from the Revit model, but it can't tell me what the calculation period is. So I'm going to go and fill that in. I think we said 50 years. Now that it's saved, we'll go back to the results page. And so from here, we can see what our total footprint of the building is. You know what, I think I need to fix something. Let's just double check the building area for this. Okay, so it didn't take it over correctly. So I'm going to fill that in. So again, this is one of those areas. I'll show you what I was looking at, how I discovered that. But there are a couple of places where if the data doesn't look quite right, often there's just a small error somewhere. So in my case, it didn't pull the floor area correctly from Revit. So it was showing that my carbon emissions per meter squared were exceptionally high, because all of the materials that we've just imported only took up a single square meter. So there was the emissions were extremely high for this building. So so now we're back into a more reasonable area. Of course, this is just a structural model, so it's low. This should be in the hundreds for building of this type, but this gives us a starting point. So again, we have all of our life cycle stage information. We can go through our completeness and plausibility checker. Like I mentioned earlier, it's calling out saying, hey, are you sure there's no glass in this? Are you sure there's no mortar? Like you don't have any brick or concrete block or anything like that. And we can double check all of this. If there's no insulation, make sure that there are good reasons for that. So yeah, that's it for this. Now let's go back to our project dashboard, and I'm actually going to pause here. We have 20 minutes. Does anybody have any questions? I realize I've just been going on for a bit and didn't stop for questions. So is there anything that anybody wants me to fill in before I carry on?
As is responding, it was not clear. Thanks for your time to go this much in a detail. I know in summer school it will take a session or two just to review all these features.
Mm-hmm. Yeah, we definitely go into a little bit more detail in the summer school. Given the time, I did kind of blast through some of this, and yeah, it's So yeah, I guess if there's no questions, okay, yeah. So Sapir says I already answered his question, so here we go. Last thing I wanted to go through here is the materials query. So how do we change materials once everything's been imported? Actually, what I should do, let's go back. This is a good practice to have, is always maintain your baselines. So I'm going to make a copy of this Revit import. Leave it, copy of Revit. The purpose of this is so that we know how much any of the changes that we've made are actually affecting the original design. So as you can see now, we've got 4 different building designs that we can compare against each other on a global warming potential basis. The Revit model that we just imported has no wood in it or any biogenic carbon products in it. It's basically just concrete and steel. So there's no biogenic carbon storage shown here. But as we were to add things, that would definitely be reflected in here as well. So so now from our copy, I'm going to go into our building materials query. And I need to move this out of the way. And yeah, so from here, I'm actually going to close. I'll leave that. So we have our filter tool up here again that we already went through. We have our building broken out into a number of different categories. So we have our foundations and structure, vertical structures and facade, horizontal structures, beams, floors, roofs, other structures and materials. And then not shown here, but just because the data wasn't there, is our external areas and site elements. So that's basically retaining walls, landscaping, those sorts of things. We can model for that as well. And then building technology as well. So that's our like mechanical, electrical, plumbing, these sorts of things. We can add that data also. It just wasn't in the Revit model. So it's blanked these out and it just to kind of declutter our desktop a little bit. So if we wanted to, let's say, let's find a larger quantity material here. So let's go with this. That's actually square meters. Okay, so I'm going to choose this one. So we've got 600 cubic meters of this particular concrete. So if I pop open the data card, right, I forgot to explain this earlier. So when I was looking for a data card that had an EPD linked to it, like I cycled through a few of them, and I chose not to go with those ones because they did not have an actual EPD linked to them. So in a lot of scenarios, where specific data was not available, what we've done at OneClick is created basically publicly available private EPDs. So they're not third-party verified. They're not perfect, but we've figured out what the process is, and we've localized energy. We've taken localized energy data to estimate what the carbon footprint for that product would be if it were to be made in that area. So this is one of those products. So this one's from Canada. We can gather, okay, so this one's been internally verified, so to the best of our knowledge. And so anytime you see like these little question marks, definitely take a look at those, because like there's often when we take EPD data and run it through a quality control check, sometimes it doesn't pass. Sometimes it's not great. Sometimes it's mediocre, but it has issues. We will flag that. If it's terrible, we won't add it. There have been circumstances where we've found data that was, like, I'm not exaggerating, 1 million times off of what we would expect for a product like that. We don't publish data like that, but if it's slightly problematic, we will still add it because it's often valuable. We'll just flag it and say, what we found was wrong with it. Maybe maybe that particular EPD is out of date, or it's as one of the ones we were looking at earlier, or it's in this case it's internally verified. So it's take this one with a grain of salt. But we can still use this data. But in this case, we don't want to. We actually want to find a better product for this this particular concrete. So we can do a few things here. First, I want to talk about transport before we swap this. No, we're going to swap this to a different product first. So so let's do that. Let's just go change, and we're going to replace. So again, our data card pops up and it defaults the filtering tool to what category is this product. I want to filter, actually, I'm just going to leave that open. And let's just go with our very lowest concretes, and we'll click the drop-down menu. We can either, if there's a specific product that we're looking for, we can type that name in. If we want something that as like, look, this one is fairly specific. It has 30% fly ash content, 28 to 35 MPa, but it's generic. But there's a little bit of additional information in there. But we can put 30% fly ash in here, and it's going to find us the EPDs that have that match that. So we can just click this drop down, and again, okay, so it's only showing us the best quality concrete. So we've got a couple in Norway and a couple in Canada. Since I'm in Canada, I'm going to actually no, because these are the ones that we're already using. Let's this isn't the perfect example, but I want this plant specific EPD that is from HGB Beton, and let's have a look at this one. We can pop open the data card with, again, it's always the question mark. Again, we can download the EPD. We can look at the environmental profile of this. We can see the technical characteristics of it if we want to know a little bit more information about it. So this one has less fly ash in it. So because I guess there were limited options that have 30%, One Click has found a couple that have an alternate. So I'm going to select that one just for the sake of this project. And let's save that. That's it. So that has been swapped out. It's done. We're going to go back to the main dashboard in a second, and hopefully that's made a bit of an impact since it was 600 cubic meters. But we'll see. Before I do that, though, I just want to show a couple of elements here that are important. So our transport to site, if we know, and we should know, based on where the project is and where we're sourcing the concrete, how far the concrete needs to travel by mixer truck. So we can override this. Let's say we know that it's only 22 kilometers, and if we wanted to change this to a different transport method, we could. But so let's say it was traveling by cargo ship, we can, or by barge, we can send that, we can do that. But I am going to, oh shit, I just unhighlighted it. Okay, now I need to find it. Let's see. So that was mixer truck. No, I can't find it. So there we go. Okay, and then so we also have a couple options here with so if this is a half fill truck, we can do that as well. So that truck is going to be running a little bit more efficiently, but because it's not carrying as much weight, but it's also per cubic meter that's being transported is going to be consuming more just because of the wasted space. But so let's assume that we're filling all of our trucks. with concrete, it's installed for life. Like that's the assumption. There's no maintenance or repair or anything like that for these products, generally speaking. And then at the end of life, what are we doing with this product? Are we crushing it? Are we landfilling it? Are we doing nothing with it? There's a variety of different options there, and it's different for each product. So depending on what product we're using, we can do a variety of different things there. So we're going to go back to the project dashboard and see if that, oh, I didn't save. Let's save first. There we go. Let's try that. There we go. Okay, so you can see we've reduced our carbon emissions by a little bit. Looks like 40 or 20 tons or so, not a lot. So it's kind of hard to see on the chart here, but on my screen it's showing just a little bit lower. But we can see how the when we highlight over, it's showing us a little bit more detail. Like this one is what would that be, 0.32% lower than our baseline from the Revit model. So this just gives us some usable information. We can go through each individual product in this project and do that, make those changes and see how they result in the overall project. So I'm going to stop here again. I wanted to leave at least, well, I wanted to leave a lot more than 7 minutes for Q&A, but I'll pause here and see if you guys have any questions or anything you want me to dig into a little bit deeper.
To be honest, from my side, I've never goes for this much detail in my LCA models, and especially on figuring out that you know, when I export from Revit, I've thought that it found a specific EPD that's matched with my product. Now you said it's matched the best fitted product. I was curious, okay, what's wrong? But you know, there are lots of options, and I just click on next because I assume that it's run on background. It was so insightful for me.
Totally. Yeah, that's really important. It's because often when you're designing in Revit, you're not detailing the specific manufacturer and the exact concrete that you're looking for, right? So, and OneClick doesn't know that. The software will take the best information that we've given it and link based on that. You know, in Revit, we're not going to detail the manufacturers, so it's just not something that we do. So it's but if you, I don't know, I'm using this is a terrible example. If you specify a Miele dishwasher specifically, assuming Miele has EPDs for their dishwashers, it's going to go and find that EPD. I say it's a terrible example because Miele does not have EPDs for the dishwashers, and that's one of those elements that shows up in when I import an architectural model. The one from Autodesk, it always comes up. It's like there's no EPD for the Miele dishwasher, so I have to find something else. Yeah, if anybody wants to jump in, feel free to throw your mic off, or just tell me if anybody has any feedback. If that was hopefully it was good use of your time.
It was perfect, more than good.
Great. Okay, well, if I guess I'll stop sharing my screen here. If anybody doesn't have any questions, maybe we can give everybody their a few minutes back at the end of their day. Or are you guys finished the course, or do you have another session to go through?
We have another. First of all, Thank you so much for your really good presentation. And we have another session tomorrow. We talk about more about molecular chemistry, and our students will work with this software. And then we talk about regenerative design, that is considering the materials, and both materials and some technologies from energy, such as cooling and heating, and we will put some information from these applications together from Ladybug Honey together with one CA. And yes, we have another session tomorrow, and I suppose that our students will work with demo license, yes. And okay, if anyone has some questions, please ask them. Okay.
Great. So I will make sure that the trial license is ready to go tomorrow. I'm not sure what time zone everybody's in, but we've got a few people that do start in like the Eastern Asia time zone. So at the latest, it'll be the European team that gets it going. So around Greenwich Mean Time. They're actually in Finland, so it'll probably be a little bit earlier. So that should be resolved, provided I gave them everything correctly this time. So but I'll make sure that this doesn't get forgotten, and you'll be up and running for tomorrow.
Okay, great. Thank you.
Great. Okay. Well, thanks for inviting me to join you guys.
Thanks for joining this session, and it was out of a scope. It's perfect, everything.
Great.
At least from my side.
Good to hear. Okay. Well, enjoy the rest of everybody's Sunday evening, I guess, for a lot of you. And reach out to me if you have any questions.
Definitely.
Bye-bye.
Bye.